Check, check, test, test. All right. So, don't have too many people yet, but actually let me get one more thing going here. Let's get this going. All right, good morning. Okay, I got a few people now. So let's go ahead and get started. I think I got everything up. Let me check one more thing. Yeah, okay. I think we look good. All right. So just kind of reminder about we've got our second assignment up. I've checked. It looks like a lot of people have accepted already. So, if you haven't accepted the assignment, you should go ahead and accept it and at least kind of read over the stuff to do. So, I do hope to get into that a little bit today, the specifics, but probably next week we'll be more dedicated to talking about the specifics of the second assignment, see if people have questions on it and stuff like that. So, I think I was going to go ahead and continue on from looking at some of the lecture notebooks a little bit. So I think probably maybe the most important thing to do today is review some of the materials that you're supposed to be using. So let me just remind people about the stuff in here. So yeah, we are looking at the chapter 2 of our hands-on machine learning textbook. So it's kind of really a big picture, end-to-end sort of example of doing some stuff. We got started on that on Tuesday. And I want to say a few more things about that stuff, and then maybe talk a little bit about statsmodel, because that's not really in our textbook. So I can maybe start giving you some specifics about some of the stuff you'll need to be familiar with for the second assignment. All right. I think I'll go back to my notebook on our web browser here. So last time we'd mostly kind of gotten through the first one on kind of data exploration. So kind of as a reminder, this is kind of a good one to go back and refer to this chapter and the appendix in our textbook when you're thinking about the project for this class. So you'll want to pick a data set and you'll want to start off, and I hope most people get a big enough of an effort on their project for the class that you break it up into multiple notebooks. So it might be a good idea to think about having just one notebook where you do some data exploration. So you do some things where you try and show what you learned about the data set in terms of what features it has and the attributes, and beginning to think about the distributions of all your features, and exploring what your label is, your target is that you're going to try and build a model for. So that's all the stuff that you're supposed to be doing kind of on the exploration phase. Okay, so and pandas in this class, you'll get familiar with that library. That's probably its best, one of its best uses, main uses is reading in a data set from some source, but then using it for exploration, visualization, stuff like that, and also for cleaning. So for taking your data set and modifying your features and adding new features or combining features and things like that in preparation for doing some modeling with it with a machine learning library like Scikit-learn. Okay? So yeah, we were, if you looked at this notebook, we mostly were looking at using pandas to look at some basic things. So to describe the numeric features, to get a little bit of a handle on which things might be missing some data. There's only one missing data set in this, one missing feature in this data set from our textbook, which we'll do. There's a little bit of an example of doing some data cleaning. So one of the things we'll do is do something to handle those missing items in the total bedrooms. So it is kind of important to get an idea of not only what features you have, but maybe what their ranges are. So that's where you begin to get an idea, a feel for what's in there, and possibly problems that there might be with those features. So our textbook does make a note of some of these seem to be clipped at maximums, like the age and the house value. So particularly this one is maybe interesting, potentially problematic, since that's going to be what we're going to use as our target for a regression here. We want to try to build a model that will predict the house value or the house price in these different counties or political areas here that we're working with. But another thing, we'll talk a little bit, or if you've read this chapter, it talks a little bit about another common thing you need to do is scaling your data. So many of our machine learning algorithms, modeling classes that we use are going to be kind of sensitive to the scale of the data. So what that means is that so all these data are of different scale. So we may or may not want to use longitude and latitude, but the housing age goes from 0 to 50, but then we've got other things that go from 0 to what is this, 350,000 or something like that. Although all of them most all of these are going from 0 to somewhere. The upper end is different. The problem is that for a lot of the models that we use, it's going to be multiplying this feature times some weight. So some models can have a difficulty overcoming that. Things that have a much bigger scale or a much larger range will just drown out things that have small scales or small ranges. So anyway, I'm jumping ahead here a little bit, but this is one of the things that we'll look at in this talked about data cleaning. And often we need to scale our data so they all have a similar range, like from 0 to 1, or maybe from with a mean of 0 and a standard deviation of 1, right? So and it's easy to take something from the original scale and map it into that so that they all have a similar kind of a scale. Okay, so anyway, that was kind of where we had gotten before. So let me just say a few things about the last part that we didn't talk about. Then maybe I will talk about the cleaning steps in there. So another thing about this section is this is kind of about visualization here. So a good tool if you're exploring the data is to visualize it. Okay, so this class isn't primarily about building figures and good visualizations, but kind of secondarily we'll touch on some of the things that make a good visualization. So labeling your axes, using clear legends, other kinds of tricks in order to make it better so that you can look at a figure and get lots of information about the data set, right? So, that's really what this last section is. I probably shouldn't spend too much time on it. I'll let you guys read through it. So you'll know if we use latitude and longitude, we can use, I guess, some of the points of these. We had practice on this on the first assignment in Pandas, though we can use some of the convenience features for not only getting information about the data, but visualizing it, right, real quickly to get an idea, to explore the data. So here we're just plotting latitude and longitude. So if we know California, this is really ends up showing us the kind of the outline of the state. We get an idea of the population center. So there's actually kind of three, right? There's the San Francisco area and the Los Angeles area, but the kind of the agricultural. This is the area out there where there's a lot of agriculture and stuff happening up against the mountains, the valley kind of area, I think. Not that I don't know a lot about California really, but yeah. So real quickly that it's a little bit tough to see the density of these because they overlap. So if you add a little bit of color coding or a little bit of color alpha, you can more clearly see that really the two dense areas, maybe a third one here, but the two are the Bay Area and the Los Angeles area in the Northwest and down in the south of the California there. So you can do lots of things with visualizing. So when you've only got 2 dimensions, you have to start using color, shape, and other stuff in order to get other information in a plot, right? So that's what the textbook was demonstrating here. So, here we get an idea. We're using color for the house value, so you can see that the expensive properties are in those 2 major population areas right on the coast. So all the people on with ocean views in particular areas in those 2 places in California have the highest, most expensive property values on average, right? So even though we've got quite a bit of population in here, most of these are on the lower end of the scale, right? And we're using size here to get an idea of the number of people in the population. Although it's a little bit tough to see some of those, but yeah, the bigger the circle, the larger the population in that county or that political area there. Right? I guess, yeah, that was kind of the end of this. So the final sort of conclusion, if you read the textbook on this section, was, there's maybe a difference between stuff you're doing for exploration, for like a data analytics project, but the job of somebody who's doing data analytics and professionally in some context is you often have to communicate your results, your findings, your information to people. So that especially makes it important that you build good visualizations and figures and things, and so that means labeling things so that people can understand them well, and using legends and all the tricks of visualizing and using different kinds of things so you can get more than 2 or 3 pieces of information in a figure, help people understand kind of the layout of stuff. So. So another thing, one of the things that you have to do on your assignment that you should be working on right now is we are going to do a regression. So this example from the textbook is doing a regression problem. So the house prices are some real value number. If we remember back to that range, I think I'll just go back to it real quickly. So back to the range for the housing values. It was whole dollar value amounts, but any time that you can think of it as like a real value number, so the range is really like $10,000 to $500,000, but potentially there's an infinite number of things that we might want to predict, or for the data that we're going to be used for training. Essentially, it's unlimited. So that's different from a classification problem. So I've already mentioned those 2 things. We'll spend a lot of time. We'll either look at we're trying to model a problem that's a classification problem or a problem that's a regression problem. So for the second assignment, we're doing a regression problem. So it's a real value number that we want to predict. So we need to use a model that does regression on it, right? So So, well, but in either case, I'm not, whether you're doing classification or regression, I mean, you still want, another thing that's important to know about your data is how correlated things are to other things. So how correlated features are to one another, but also how correlated the features are that you're going to try to use to build a model with the thing you're trying to predict, right? So if you have a feature that's really highly correlated with what you're trying to predict, you're going to have a relatively easy problem modeling it, because you can use that feature to directly build a predictor, right? But if you have lots of stuff that's very low correlated with what you're trying to predict, the problem will be tougher, right? So there's a lot of noise in that you have to get a signal out of to make a prediction. So I think I've got a little bit in my notebook about correlation on the review and statistics. I won't go into that. So the stuff that's done in here when we do a this core function does a correlation, does a standard Pearson correlation between all the numeric features. So I think you have to do the same thing on your assignment too. So it can only correlate between numeric features. So if I wanted to correlate the ocean proximity, I'd have to convert that into a numeric value. We haven't done that yet. So all we do here, first of all, to show correlation, we just drop any non-numeric feature and then run a correlation on it. So so here you can see. So look at this data here. This is just the correlation between every feature and every other feature. So of course each feature is perfectly correlated with itself. Correlation could go from -1 to 1 in a Pearson correlation. And where 0 means that there doesn't seem to be any relationship at all between the two features. 1 means it's perfectly correlated. -1 means it's perfectly reverse negatively correlated. Okay, so really one important thing I think for the second assignment is, just because it's negative doesn't mean, so a negative, the most highly correlated feature might be negatively correlated. So even though the correlation is in the reverse, when this feature is high, the thing we're trying to predict is low, or vice versa. That's all it means. It's the reverse, versus if it's positively correlated, when the feature is high, the thing that's correlated with is high. All right. So, but it's the magnitude of the correlation that's important. So if we look in here, except for the diagonal, which will be perfectly correlated with itself. So we might want to ask, the first thing we might want to look at is, so we're going to try to predict median house value. What looks like is going to be most useful for predicting the house value if we're trying to build a regression model. So maybe not unsurprisingly, income is pretty high, 0.68, right? But the second highest is probably the total rooms. So this is like the total number of rooms, I think, over all the houses in that county, or like we have a negative correlation with latitude. And this maybe shouldn't be unexpected either, right? So just another quickly, idea of what negative correlation means here. So there's probably a larger amount of expensive houses than in this area than in this area. So the bigger you get in latitude, the more likely it is that you're going to have a house price that's higher. So that's why it's negatively correlated. So when you go lower, I mean, it is split, it is bimodal. But if there's a lot more expensive, higher houses in the upper latitudes and the lower latitudes, you'll be negatively correlated on by that measure. Right? That's kind of what we're seeing when we look at the correlation matrix here. So yeah, I think we're still good So yeah, I mean, sometimes again you might want to. I mean, we're directly plotting all the some of the combinations of. So we picked some of the things that were most highly correlated here to get a feel for the correlation between these and the median house value. Right. So if something, the Pearson correlation, the measure is when it's highly correlated, you'll tend to see that you can fit a line to it, and that's really kind of what a simple linear regression is. We'll get into the details of what we mean by linear regression after this unit in this class here. But so if it's not correlated, it'll just look like a big blob. But if it is correlated, you'll get something that will kind of seem to have a trend. So, like if we're looking at median income with the median house value, which was the most highly correlated. So that's this figure here, or the same, right? So it's just mirrored on this one here, but the axes are flipped. But yeah, this would be the best one to use because normally when we're plotting something like this, you want to put what's known as the independent variable should be your x-axis here. So here we're going to use median income to try and predict the house value, right? So normally you put what's called the independent variable as your x-axis, and the thing that depends on it, the things you're trying to model, that you're going to say use this to try and predict that should be on your y-axis, your dependent variable. So you can see here that I mean, it's definitely kind of a trend. So the higher the median income, the higher the house value is. And also you can see a little bit of that clipping effect here at the top. So there's a clear indication that some things are being clipped at 500,000. Looking at that one. Okay, so feel free if anybody wants to talk. Yeah, there was just that specific one. I think so a basic plot. I think I asked you to do this a couple times in the second assignment. So if you're trying to get an idea of how some measure correlates or predicts some other measure, you do a basic two-dimensional plot. So. I mean, you can use matplotlib, or you can here we're just using the convenience function again from pandas to specify the x-axis and the y-axis to give a scatter plot of those. So yeah, final mention here. This is kind of the beginning, actually, really of doing some data cleaning. So one of the things you might do to try and build a better model is take your features and clean them, or maybe make new features that are better for building your model with. So I don't think I'll go into the details too much of this here, but it might make more sense, or we can try some things out, like instead of the total rooms, maybe just the average number of rooms in each house might be a clearer signal, just to pick one of these that our textbook did. So here we created a couple of new features and added those to the data frame and tried a correlation here. So now we're just looking at the correlation between all the features, including the new ones that we created, and the housing value, to see if we had any change. So like our new ones, like the rooms per household, notice is a little bit better than the second biggest one we had before, right? So that might be a useful feature. Although the bedrooms per room, notice is actually our second most highly correlated, even though it's a negative correlation there, negative 2.5, right? So. Okay, so let's look at the next one here a little bit, say a few things about data cleaning. you might not, we will need to use this. I don't think I really asked you to do any test train split for the second assignment, but this will be important for, I think, the third assignment and all the rest of the assignments, or in a couple of assignments. So let me just mention a few things about this section here. So a common thing that we need to do when we're doing machine learning, when we're training a model, is the real goal of making a model that can predict things is to, we want to know how it does on data it's never seen before. Okay, so it's when you train a model with a set of data, it's very easy to overfit the data. Okay, so I'll just jump right to the conclusion on this. So you can easily build models that will perfectly, for a data set you train with, that will, if you ask it to give the prediction, will give a perfect prediction for all the data you train with if you overfit it, right? But that's not necessarily a good model, because overfit models, if you ask it to predict data it wasn't trained with, they'll perform poorly, okay? So to detect if you're overfitting or not, the common practice in machine learning is to, the most basic idea is just to split your data into two data sets. So split it into one data set you're going to use to train with. So you take all the data, but you keep some of it out from your training. So you keep some of it out as a test set. All right. And then later on, we'll look at splitting it into three parts: train, test, and validation. We need to do that sometimes. But for right now, we can just concentrate on a train and a test set. So yeah, this is an example of a function where we did it by hand. There's methods in Scikit-learn, so we would normally just use the standard methods in Scikit-learn to split a data set into two. But there's some subtleties about splitting data sets that's discussed in here. I'll just touch on a few points of this. So I mean, you can easily do this by hand. Here, if we want to, you do need to be careful about making certain that you do some randomness when you do this kind of a split, because this is another thing when you do an exploration that you want to know, because sometimes you'll get data sets that, for example, might be sorted by the housing price. So if the data set that we had was sorted that the lowest housing price was the first sample, the row 0 of the table, so on up to the highest one. If you just did a simple split where you took the first 80% for your training and the last 20% for your testing, you would have all the lowest ones that you would train with, and so you'd get a bad split. Okay? So you have to know if your data has been sorted or not. And even if it hasn't been sorted, though, it's usually good practice to pick your, to do a random split somehow. So this is an easy way to do it. This function from the textbook, if we wanted to do it by hand, the default methods in Scikit-learn will do a random shuffle split, similar to what is done here. So in this, we're using fancy indexing. So we create a list that goes from 0 to the number of items in our data set. So in this case, we had 20,000 in some.